before I forget. Okay. Cool. Well, hello everyone. Welcome back to the PyHC Telecon series. It's been a little moment since we last had one. Last big thing we did was our summer school, which went super well. As far as overall announcements goes, the Dash idea registration is officially open. I'll be sure to send out the link for registration in the follow-up email to this telecon. So get on that. Hope to see many and or most all of you there, in person or virtual if you can't make the leap across the pond. And then the second announcement I have is that our PyHC session for AGU 2024 was officially accepted. So I'll be sure to send out information for that as well. And yeah, be on the lookout for abstract submission deadlines and so forth. So that's what I have on my end. Sean, I'm sure you've got a couple things to say.
Yeah, thanks. And I saw the email from AGU about that, so that's exciting. Thanks for putting that together. Uh,
Yeah.
I'll also pitch that at Dash, I got a session accepted to talk about generative AI stuff. So if you've been playing around with any cool generative AI tools, I'm going to doubly encourage you to submit something to Dash. I'm hoping it'll be a popular session this year. But other than that, I have started the process of writing a new FEP to replace our Python versioning standard. I won't talk about it in depth here because I want to give Daniel his time. But if there is time after, I will go back to it. But basically, uh, the elevator pitch is we've decided that it's not necessary anymore to have a standard that explicitly says you should support Python 2 instead, sorry, Python 3 instead of 2, because Python 2 is all but dead now. So instead, I'm suggesting basically adopting new Python versions for at least 3 years after they release and adopt the new ones within 6 months after they come out. There's also some questions about whether or not we could pull in some package version management policies from Spec Zero for people who have heard of that before, which would help coordinate the versions everyone's using for like NumPy, Matplotlib, Panda, other really popular packages like that. I will drop a link to this PR in the chat for people who are interested by the elevator pitch and want to check it out. But other than that, I will keep it short so we can move on.
Awesome. Thanks, Sean. I saw that you had also sent out an email to the list with a survey for people to fill out.
Oh yeah, thank you for reminding me that I had done that. Yep. This is for the Science Platforms Coordination Working Group that we're a part of here. Um, Basically building some sort of a base environment that people could use in heliophysics. There'd be some funding to like stick it up in a browser somewhere so you could go run some, code in a Jupyter notebook in a browser or things like that. Picture kind of a Google Colab, but with some heliophysics goodies baked right in. And yeah, I did send a link to a survey and hoping people will fill that out. So check your inboxes or even like, I think the general channel in Slack if you didn't see that. And maybe I'll post a link there too in chat.
Awesome. Thanks, Sean. Okay. Well, Daniel, whenever you're ready, the floor will be yours. We have
Thank
Daniel
you.
today to talk to us about this effort he's working on with Helio data.
All right, sure. How's the sharing? Is it working good?
Yeah.
Okay, great. So I'm going to talk today about the Helio data website that's been development in HDRL. Its end URL is going to be at helio.data.nasa.gov. And there's a whole team. I'll talk about the team that we have here later. And I've opened up the firewall for the staging instance for just today. And at the end, I'll send out a link so you can try it yourself. And there's a Google feedback form where you can submit some comments and thoughts. So a little about myself. I know a lot of people here, but some people I don't know. I'm a software project manager with HDRL, and I'm a research heliophysicist at NASA Goddard. I've been working in heliophysics since 2016. I designed and led several of the key components of the MMS FPI SOC, and currently I'm a lead architect of the WSA space weather model. I work on the Marble Kinetic MHD model. I work on data compression research with the Center for Analytics, and I'm the founder of the CCS Pi library, which is one of the PyHC libraries. Before I got started in heliophysics, I worked in information systems and NASA Earth Science, part of the EOS DISC program at one of their DACs over there, where I got started with a lot of data portals, visualization, infrastructure, and even some like social collaborative platforms for scientists. So I'm interested in large software architectures, human factors and usability of IT and heliophysics, applying systems engineering practices and development processes and research environments. So if you're interested in any of that, please come talk to me and we'll chat about it. I have the Float 64 license plate in Maryland, which I think is pretty cool. And
I was just about to give you an applause for that license plate.
thank you. Okay, so this presentation, I'm going to start with the overview and concept, like what we're building, why we're building it, and the way we're trying to build it. I'm going to just go give a preview and live demo. I'll send out the link and I'll share my screen and go through some parts of the site. And then I'll get into the technical discussion, software architecture, um, uh, and more level details for people who are interested in that kind of thing. Okay, so starting off with the concept about data discovery. This is a website for data discovery in heliophysics. And this project has started as a long-term strategic investment to make NASA heliophysics data more findable and accessible. And there's a lot of projects that are doing this. This is a hard money project from NASA HDRL, rather that allows it to um, uh, adopt more of an iterative life cycle rather than the kind of one and done grant kind of cycle that kind of I think hinders a lot of projects, unfortunately. So data discovery is learning about, finding, and more richly connecting to data, all of those things together, and I'll talk more about that. HDRL conducted a user survey in October 2020 about data discovery, asking users from the community and that we had reached out to about what they think the major challenges are. And the user demographics in this had a mix of early and late career, people between modeling and data, people between operations and research, and so on. So trying to be representative. But people came back with identifying that the biggest needs for data discovery were these points, and these are verbatim from the form that they checked. Was that I'm interested in phenomena X. What are the related data? I'm interested. How do I access the data model and document that I'm interested? So where do I, once I have a data set and everything that I'm interested in, how do I find these associated pieces of information that are connected to that data set? So that's kind of our research, our user testing that's kind of driving the creation of this project, and where we started off. So we sought to build a system that addressed these needs, and we kind of trying to do it in a more modern way compared to some of the other traditional software pieces in the NASA heliophysics ecosystem. So we're trying to use regular user feedback and regular feedback cycles, make sure that we're aligned with user needs in a kind of an agile sense along the way. And we're trying to apply usability research on human-computer interaction throughout the design process. And we're trying to particularly look at how people interact with government IT systems and project a good image of the NASA heliophysics program as a government program to the public. So this covers like in a visual aesthetic sense. We want buttons to look good, we want borders to look good, blah, blah, blah. But we also want in a more broad and deeper communication, psychological, and like usefulness sense, we want something that people are excited to use, and that when they first use it, it feels natural and fluid to them. So a little bit about the design philosophy of how I've been thinking about um, information systems and heliophysics. There's kind of a spectrum between like the human and the technical side. So where the human side of technology that I see There's a natural way that we think of, we're in our head about these concepts in science and in programs, that when we're not under pressure, we're kind of that, not when we're talking in a proposal, but just when we're talking inside of our head, how do we think this works? Um, and we are people, and we're impressionable by aesthetics and charisma. Something that looks nice does make an impact on us, um, and we have our own ways of doing things when we're not trying to appear smart. This is a big thing in science. We want to meet people where they're feeling natural. On the other side, there's kind of this technical and industrial perspective of data, kind of going back to almost the Dewey Decimal System of a numbering system, and everything's organized in a tree, and it's very mechanical. This is kind of how computers work operationally. It's a very rational thing. It's it, it's uh, it's true that it's very logical, but it's not always the most natural and human way to go about things. It takes a lot of effort and then cognitive energy to spend doing things like that. So with our project, we want to meet people at the human perspective. We want to create a branding for NASA heliophysics on the web, that people who come to this site say, "Oh, those heliophysics people, they seem pretty smart. There's a lot of energy in that field," and that it's vibrant and lively and something where things are happening, that congressman who stumbles across this website is thinking, "Oh, those heliophysics, they must be doing something important." So I'm going to talk a little bit about how we approach this problem of data discovery, which is really this theory of context. A lot of this might seem like common sense, but kind of a lot of usability is bundling a lot of common sense ideas together, so you think about them at the same time, and then you can implement them more easily. But this notion of context is content that helps associate the data with the user needs and transition them to a decision on whether they're going to use the data. So they're looking for information about data. They're presented with the data and the name of the data set, and all the technical information about the data set, but also information around it that helps them place it in their understanding, so they can make a decision: is this data that I want to use? The next level of commitment, downloading and opening code and reading data. Do I want to go to that next level of commitment? So there's been a lot of research in like information systems and technology and usability on what constitutes this kind of context that helps people when it comes to data discovery. And these are broad terms, not necessarily just in heliophysics, but in machine learning and life sciences and so on and so on. So context is generally these five things that I've listed here: things that provide a backdrop of phenomena and setting, things that make an association with a familiar community, things that are connected to a group around it, especially like a group of people that you think about, something that leads itself to a particular action around the data, and something that people do, like an around like an action that you associate with people having. So to put this into the context for heliophysics, these backdrop of phenomena and settings, this comes into our notions of regions of the space environment. We have coronal holes, we have the solar wind, the radiation belts, different places that things happen in the heliosphere environment. There's broad occurrences, like transient kind of effects that start and stop. They're not happening all the time. They're not always there. Auroras, coronal mass ejection, solar flares, radiation belts enhancements. And this is a little bit more of a fringe thing, but sometimes a setting can be a mode of inquiry. We're studying this through simulation, or we're studying this through machine learning. But these are backdrops of phenomena and setting that can when placed next to the data set, help people understand, what am I supposed to think about this, and help them make the decision. Another important piece of context is this notion of a familiarity with the community. Big communities in our field are GEM, Cedar Shine, AGU Dash. In addition to these big conference type of communities, and sometimes journals in the case of AGU, there's mission communities, the MMS community, the PSP community, that have these telecons, regular that have these regular science team meetings. And it's possible to be a familiar face within the MMS community or the PSP community and so forth. So they're kind of their own spheres of community that are attached to data sets. And even within a broader than that, there's communities around fundamental science, something like theory heavy plasma reconnection physics, people who are really writing out theoretical equations. And then there's people in more applied science operationals kind of communities, people doing like closer to the Space Weather Prediction Center operations, who are doing applied space weather forecasting things to get those forecasts out and operational. And finally, the last piece of context I'll put in the frame of heliophysics is activities and people things to do with the data. So people might be looking for kind of tasks. I'm working for a power company. I want to quantify the risk of damage to my power company from ground-induced currents of the next year. I'm operating a geosynchronous satellite. I want to estimate radiation levels. How would I put my thresholds for for protecting my instruments? I'm a teacher and I want to look for something for my class to make a lesson plan for this week. These kinds of things that I'm doing something. Um, Give me something for what I want to do. So we looked at a couple of case study websites that we think are doing this concept of data discovery and um, and context really well. One of them is the Papers with Code website. So they have a search capability and a trending capability, but they also have a browsing capability. So you can go on their methods part of the Papers with Code website. If you don't know this website, it's a machine learning community website where they showcase papers that have code attached to them, and they're all reproducible, and they're often models that you can pull off the web and integrate into your own software. So they showcase like a category for generative models, and they introduce what generative models are, what this page thinks generative models are, how does that align to what you think generative models are, and you can drill down into the generative adversarial network, a particular kind of generative model, and 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 further go through levels of context to get to papers with code and GitHub repositories that you can download. And this is a kind of natural, very passive experience. It's a emphasis on reading and associating familiarity throughout the different steps. Another site that we think is doing this pretty well is the Earth Data site at earthdata.nasa.gov. They showcase their data by different regions of the Earth system. So these buttons at the top map to different things like Earth atmosphere or the biosphere or the cryosphere. And the atmosphere, for example, here in the middle, will have a page about the atmosphere, and you can find data connecting to the atmosphere. And you can even click in different parts of the atmosphere, like monsoons happen in the atmosphere, and be connected to things related to monsoons. Um, yep. So um, that's kind of the broad overview of how we're thinking about context, how we're thinking about providing useful information to the user to help them make their decision about when they're going through the site and they're looking for data. Um, how do they put things in context and connect it to what they already know about themselves and their needs to make a decision about data? So we've developed this site to fulfill these like three main goals, and these are kind of three sections of the site. The biggest one is this data discovery section that promotes findability and accessibility of NASA heliophysics data. And while we're doing that, and we have a good site together, there are a couple things that we're tacking on that are also going to play onto this. Is an unassuming entry point to NASA heliophysics data. Someone who maybe they're a graduate student and they don't have a very famous advisor, or their advisor is very busy. How can they get started learning about how all of this works? Learning about so I have a data set. What is NetCDF? What is CDF? How do I download these things and get started? Feeling like I'm prepared to go into this alone. And then there's a lot of other information in there about the whole ecosystem of data acquisition and whatnot. But and also side by side with this, we want to humanize the web presence of the heliophysics data community. So we have kind of a community showcase section. That's we have science writers that are supporting this. These are like articles, biographies, and stories about people in the community, about things being done in the community. Kind of contextualize it with that this is exciting, that this is energetic, and that heliophysics is a great thing that's happening. So this first entry point section, um, it starts with like these three buttons right here, which I've changed a little bit since I took the screenshot. It's an unassuming way to enter NASA data ecosystem. Got all of the who, what, where, and how, and the information on formats and stuff you need to get started so that you're not being thrown into the dark. And you have kind of a virtual assistant to hold your hand, or at least article content to hold your hand through through getting started. And then there's this data discovery section through a search interface and a browsing interface, finding data sets that are interesting for you through faceted search and free text search. And I'll talk a little bit more about that later. And then there's this community showcase section at the bottom with articles. These are some example articles, kind of to give a look and feel of what they might look like. But a heliophysics like none other. This article about Jane Doe. She's at a university. She is a heliophysicist, and you want to learn about her. There's cool stuff going on in Antarctica. We're doing open science, and Orosaurus is a great piece of software, and so on. Things like to connect you to the community and put side by side with discovering data makes you want to discover more data and appreciate heliophysics. Okay, so I'm going to stop sharing my PowerPoint right now, and I'll give a demo. Okay, we're good on seeing the demo?
Yep.
Okay, so at the top, we have kind of a search interface with these getting started buttons. This article content is under construction, but if you were to click get started, we kind of have an FAQ, very classic like website FAQ interface here. Learn about heliophysics, where the data comes from, downloading, acquiring data, and who we are. And those pages are being written about right right now. There's some splash context here just to set the tone. And down here is the ability to browse by regions. Down at the bottom is the content to learn about the community. So I'll just get started. I'll search for solar wind. It's fairly fast. So I see some data sets from ACE, Wind, Omni down here. These are ranked by a combination of popularity and how many, particularly, we're exporting data from CEDAWeb on how frequently people make plots with each of the data sets. And that factors into the ranking, but it's also based upon how many fields it matches in the variables and the metadata associated with the records. So before I go to the data sets, I'll show that there's a faceted search on the left. So these are within the search that you just made. These are the missions that matched. These are the instruments that matched. These are the types of measurements, magnetic field, thermal plasma, and more specific things. These are the regions of the heliosphere that matched. Um, and information on time resolution. You can narrow by if you're looking for a particular application and you're looking for data that has time resolution on the order of seconds, you can click seconds here and it will narrow to data with seconds. And then there's you can narrow by decade and whether it has an API access, FTP access, HTTP access, and so on. So let's just click on ACE right here. There's a landing page here for this ACE data set with some description here that helps contextualize what's going on with this data set, what you need to know in order to make your decision about moving forward with the data set. Down here at the bottom is more summary information, links to a page for ACE, a page for the region and authors, and you can see the variables within this data set with units. There's API instructions. Right now we're doing just the CDAS API, and I'm gonna come back and talk later. I think a thing that we want to invite the community to participate in is advising on different API instructions that we can integrate into this site here. So we have IDL and Python API instructions, but basically if you were to copy this code into a notebook, it would load a variable with the data from these variables in this data set just pulled from the CDAS API. And I think this is going to help streamline, get people copying and pasting code into their notebooks pretty fast. So on cite the data, we generate bibtext citations and MLA formats, and then there's some supplementary links there. For data sets that are connected to CDAS, there's this get data button. We can make text files, CDF files, CSV files, NetCDF files similar to CDAWeb, and we can make plots in here. This is powered by CDAWeb. Nothing that CDAWeb can't do, but plus to put in the context of this dataset landing page encourages people to use the plotting feature to explore whether they want to use this dataset. That was something that we discovered through user testing. For FTP download, a lot of people did not grow up with FTP. So if there's an FTP information associated with the data set, it provides some like summary of how to connect and links and some command line instructions if you're doing it on Linux, and what tools you'll want to use if you're doing it on Mac or Windows. This kind of HTTPS link will just go to the like Apache directory file, and so on. Yeah. So this is a dataset landing page. This is generated for each of the datasets in the system. We also have landing pages for the missions and the regions. So if I were to click on ACE right here, I'd get to a page for ACE, some description about the ACE mission, some contextual information kind of inspired by a Wikipedia info box on the right, like the PI, the regions it covers, when it's available, and some information about the homepage. And then down at the bottom, the top being kind of like an absorb information, the bottom being kind of a get and make feel inaccessible part of the page. You have the same faceted search, but restricted to the ACE data sets. So that's kind of the search part of the site, especially if you know what you're looking for and you found it before. You can go through searching, and then for a more browsing and passive experience, you can go down here to pick a region of the heliosphere. So if I'll click on Earth magnetosphere, there's content about this Earth magnetosphere, again, to provide context about alignment between the user's understanding of magnetosphere and our understanding. There's different subregions of the heliosphere here, which are similar pages. Like if I were to go to Magnetotail, there's just a similar page here. And we have a list of featured missions under the Earth magnetosphere, which are curated by our scientists at HDRL. So these are these are advertised as the best of the best, the kind of the flagship NASA missions, historically important, and that things that NASA wants to show off to the community. So in addition to that, you can go to all data sets, and then there's another faceted search for specific to that region. So if I click on MMS, there's a page here on MMS. Okay. So I think that covers pretty much the demo. I'm going to go back to sharing my slides. Okay. So about the technical stuff, this is probably what I think some of you are probably waiting for, the fun stuff. This website's written in Python and Django with a web framework similar to like Flask, if you're familiar with that. For the search framework, it's using Apache Solr, which is kind of similar to Elasticsearch, if you've heard of that. For the database, it's using PostgreSQL. And Docker is how our containerized deployment is. on the front end, it's JavaScript and React, and I like React a lot. It's been a breath of fresh air for developing complex front end applications. So an architecture of the site is we have this thing that we call HCUT, which is a Helio data catalog unification tool. Because this website is showcasing information from the SPDF, things from the Solar Data Analysis Center, the SDAC, and things outside of those two in space, we kind of need to put all of them into a common schema and a common model. If you've ever heard of the model view controller for design pattern, that's kind of what we're doing here. And this part is kind of the model. So it maps these different schemas and these different sources of information into a common schema that is used to drive the site. So that populates a search index, which provides the search capability, and we have a kind of the view component of the model view controller design pattern in the website backend. That's the Python Django kind of stuff. And then the React front end basically makes AJAX requests to the backend to get the information for the site. We're hoping to at one point provide an API for this site that'll be kind of decoupled from the front end API endpoints, for other people to consume the information that we prepared. So about searching for data, we've actually integrated with some search enhancement technology developed by the SciX ADS team. Some of our members working on taxonomy and search also work for the SciX ADS team. Um, so some examples of queries or support, it's maybe not as dumb as you might think it is. You can search for solar wind. You can search for MMS FPI electrons. You can also do these kind of filter searches that I think Google kind of pioneered these kinds of searches, or at least made them popular in the early 2000s, where you can search for electrons and filter by mission MMS, filter by instrument FPI. And if you're a power user, that can help you narrow your search results very fast. We also support kind of queries like quoting two words together, to make sure that they both appear. You can do like Voyager minus ephemeris if you want to see Voyager data, but exclude ephemeris. So there's kind of a good deal of text parsing for the query that goes into supporting the capability. Um, these are kind of stemming is a concept in search, where a word like magnetosphere and magnetospheric will match together. Like character to character, they're not the same word, but when they're kind of normalized into the same root word, they are the same word. So our search supports that kind of thing. And we support synonyms, and we have a large synonym table, which we inherited from SciX. But for example, if you search for Van Allen probes, it'll match things that have the word RBSP and vice versa. And that again helps connect people to the results that matter. So yeah, I talked about that we search multiple fields, we sort multiple metadata fields, and they're weighted differently. And we use popularity combined with the weighting of different fields to create a ranking function. That's pretty much like a mathematical function of this plus this times this and blah blah blah, equals the rank, and then it's sorted by that number. On these facets, the facets provide a way to narrow down. It's a similar approach used by Amazon. eBay uses it. Um, I mean, uh, it's a well accepted design pattern for narrowing search, but we kind of put different perspectives here. An org chart perspective, like missions. Under missions are instruments. Under instruments are data sets. So you can narrow by missions and observatories and instruments and data sources. There's a observable part. We talked to people, and people were very interested in, take all the bureaucracy of who and who's being paid by who, what's mission this is, and so forth, and just tell me, is this measuring a magnetic field at this location? Is this measuring thermal plasma at this location, energetic particles at this location? Is it going to give me the time resolution that I want? And is it going to, can I write a paper with it? So keeping close to this observable sense of discovering data, we made these different measurement types and regions and time resolution facets. And then there's how you get it, whether you, if you especially if you're writing operational software, um, the ability to download API or FTP is pretty nice to know. So you might, in some cases, prefer data that has an API over data that doesn't. A little bit more about this catacalc unification tool. Emerges these multiple schemas. The key objects in this system are data sets, instruments, and data sources, emissions, and observatories, in the sense that a data set can be linked to multiple instruments and data sources. Um, Most data sets only link to one, but there are some kind of data fusion, like Omni uses both Wind and ACE, and it's linked to multiple ones. And then instruments and data sources are linked to missions optionally. You could definitely have one that's not missing function. And we have our own taxonomy of regions and subregions, like going back to that Earth magnetosphere and under that magnetotail kind of tree of regions that data is labeled as. And by having everything in this common system, it helps us keep things general, and that in the future we can add other data to the system that's not already part of these one sources, because we kind of have just a common format, and all we need to do is map it onto that format. So we could do things like accept user contributed data sets, or data sets from other space agencies, and so on. It keeps us flexible. But right now we are scoped to NASA and NOAA missions, because we need to deliver. We have some visualization and download API integrations. I showed you that SPDF C2Web API integrations. These are put at the end, a point where the data set to make their experience richer. Data sets may be connected to other. So each data set can have an identifier in other API systems, just a field on the data set that says what's it called in C2Web, what's it called in HelioViewer, and so forth, so that we can generate these kind of API dialogues. And right now we have this SPDF one implemented, and we're hoping to, before we launch, implement the HelioViewer one. And there's a screenshot of that over there. And these ones aren't meant to take away anything, and we're developing these in conjunction with SPDF and Bobby Candy and Lan, and in conjunction with Jack Ireland and the HelioViewer team. But they're kind of just mini evaluation tools at the dataset landing page that link off to back to the tools, and provide a way to quickly, without leaving the site and making a big context switch, um, uh, tease out whether I want to use this data. And so, um, other than these API tools listed here of SPDF API, C2Web API, and the HelioViewer API, there's a number of other APIs that are attractive to us to integrate, and I think can be really useful, especially things like the SunPy Fido and the VSO APIs. Really, if you can query a list of files and then click a button to download them all as a zip file, um, that would be really convenient, and it wouldn't force users to make awkward transitions between very different user interfaces, which is research shows is a very taxing thing. Um, and similarly for Happy has plotting capabilities for things outside C2Web that is pretty good, and they look attractive plots. And just to go back and review this data API access instructions, right now we're generating API instructions with this SPDF C2Web CDAS API in Python and IDL. We're hoping to launch with SunPy API instructions as well for data sets within SunPy. But in the future, we want to expand this and involve community participation to put other APIs from PyHC in here to showcase the different capabilities and help people discover these APIs right there, and know a place to look for getting these APIs. So we're going to look to collaborate on this in the future, and we're hoping for community participation. We're hoping to hear from people like you to represent your APIs in the site in the way that you want them to be represented. All right, so before I close, this is the Helio data team. Thanks to all the people here who have contributed. Um, We've also worked with the Office of the Chief Science Data Officer and the Earth Data team, and we've had great feedback from users throughout the community. So thank you to everyone who's contributed thus far. So I'll stop there and open it up to questions and discussion.
Awesome.
I'm gonna put the link to the staging site in the chat. It's open to anyone right now, but probably after today, I'm gonna close it back up to just um, internal IP addresses, so it won't be accessible. But there's a Google Forms link there too, if you are inclined to tell us what you think.
Thank you for
Super
that.
cool, Daniel. Sorry, Sean. Did you have a question?
I was actually just going to comment that my first question was going to be, is that staging site available for us to play with? So you read my mind.
Super.
Sounds like yes. Do we have any other questions from the crew? Go ahead, Nick.
Yes, thank you. This is amazing. I'm really hoping that the field of plasma physics develops something similar. I was wondering, could you say more about what you're doing to test for like screen reader text-to-speech accessibility?
Yeah, so we're going to do a deep review of that afterwards. Later after the core features are all developed. There's actually a lab in Goddard where they have screen readers set up, and there's someone we can bring the site to, and they'll do like a deep review of what needs to be done. So we're hoping to utilize them. I've done some screen reader stuff in the past, and mostly I believe it just comes down to uh, annotating HTML tags and putting them in a proper order um, to facilitate the interoperability with screen readers. Is there any advice you want to give me?
I would, I'm not so much an expert, but I think like doing a review for screen reader compatibility earlier on can help make things easier in the long run.
Yeah, I'll take note of that. Thank you.
Doing more of like an iterative approach.
Absolutely.
So yeah,
Thank
thank you.
And just to jump in there, Daniel, correct me if I'm wrong, but because you're actually hosting this on like the nasa.gov domain, don't they actually require you to be WCAG 2.0 like web accessibility compatible before it launches?
Yeah, so there's a clause in the government IT called Section 508 compliance,
Yep,
uh,
yep.
which requires a screen reader support, generally written as a best attempt. And there are some sites who kind of make a separate mini version of the site that's 508 compliant. And yeah, there's a lot of ways to do it.
Nice.
Any other questions for Dan?
I have so many, but I want to let other people go first.
I have, I guess, just one quick one. I'm just curious, is the intention to stay like really pure helio, or will you be kind of including the whole, sun to mud kind of idea that relates to heliophysics and space physics for data?
I'm not sure I understand the question. Uh, it or kind of um, it's kind of too early to tell how in what direction we'll go and how inclusive we want to be with outside. So we're starting with NASA and NOAA heliophysics missions. That's kind of our first prerogative. That's the people funding us are most dedicated to that. There's a lot. We kind of a concept of what we think heliophysics is broadly and what will fit under that. There's some overlap with planetary, for example, like a mission to Jupiter, measuring the Jupiter radiation environment, can count as both. Um, where where it makes sense, I believe that cross-listing that Jupiter data set under something like PDS and on this Helio data site, it's in the interest of the users to have it listed on both, in my opinion. Does that help?
Yeah, that was good. I'll yield the floor to someone else now.
I guess I'm gonna jump in because it was kind of related to what you just said. You're going after the NASA and NOAA stuff first because those are your funders at the moment. How long are you funded to work on this? And yeah, I guess I'll ask that first. Like, is it years or months?
Years.
Years. Okay, good. So you got some long-term support, and it'll definitely continue on. Um, and then I guess the next question is, you were talking about there's all these other APIs, obviously, from PyHC and other things that you could tie into. And I think in the perfect version of this tool, you would pretty much just collect all of them and run them through your HCut unification tool and then just have it all here. How can you prioritize who gets to be worked with first once NASA and NOAA are satisfied?
Well, we put the user first. So we evaluate what serves the user. APIs that are rough around the edges um, uh, need to be taken with much more caution. APIs that are reliable, work every time, and all the data is represented well are much more attractive than kind of prototype in progress. You know, will work one day kind of things.
Yeah, no, that makes perfect sense. And I guess I'll just offer that if any of the networking we have here at PyHC can help you reach out to API developers or, get calls for people to come plug in their API to this tool, we'd be happy to facilitate that.
Thank you. I appreciate that. We're going to want to take you up on that.
Um, Maybe one yes or no question real quick, and then I'll save the rest of mine. Um, are you caching any of the data that you're serving on your website, or are you simply just being the middleman and making API calls out to other servers and then hoping they're alive to serve things on your website?
So all the dataset mission and instrument landing pages are all cached.
Oh, see, that's the awesome way to build a website like that and the hard way. So kudos for going down that road.
Yeah, and you actually, if you're building a search index, you don't really have an option to do it any other way, because you need to populate like a search engine and search all the data. You know, you can't if I'm searching for solar wind, I can't make 1,000 API calls for every CETA web data set to check whether they all um, match solar wind. Yeah.
Wow. So then potentially if this site gets off the ground and integrated with all the APIs because of the caching, you might even be a more stable way to access this than other websites because our APIs tend to go down a lot.
Hopefully, yeah.
Wonderful.
I think a clarifying question is due here. So I'm not sure there's understanding on both sides about data. So obviously, I think you're saying, Daniel, that the metadata is cached, but is the data for the plots cached?
The metadata is cached. The data is not cached.
Right. That's what I thought. Does that help, John?
Okay, that changes how I was viewing that a little bit. So thank you for the clarification.
Okay, good.
Okay.
Rebecca, you want to go ahead with the questions you have in your mind?
Sure. Just one, really. I was about to ask John if he was good for me to go. Okay. What I guess this is a teaser question. So one of the things with the open science goals is to link data sets to the things related to them, such as publications and software and so on and so forth. Would it be easier to just build off of maybe a SciX API to get that information linked to the website somehow, or would that be good to incorporate into space? I mean, maybe this is too early to ask the question, but throwing it out there, just thinking about the efforts that have been going on at PyHC for a while to try to link software to missions, similar data.
So yeah, to answer that, I'd say before we get into APIs and do we use this API versus this API, what do we want to do is kind of the big question. So what I would think we would want to do is like, for example, have a tab under the mission papers that use this mission. If we were going to build a feature like that, then different ways we could do that. If ADS has a capability and it's a stable capability and it's long-term supported, then something like that could be implemented. If no one else is doing it and we need it, and it doesn't look like anyone else is going to do it for a long time, it's not too hard to collect mission papers and then query a citation graph API to see who's citing that paper and just list them.
Thanks for that. Could you provide maybe some similar comments on linking to software, given this is the PyHC community? I might find that interesting.
Sure. So we want relevant information for like each of these regions and each of these missions, and we're showcasing a lot of data sets about these regions and the missions. Papers about the data and the missions are useful. Software about the missions and regions are interesting. For example, you're studying the magnetosphere, you might be interested in this PyMMS package. And I don't know if that's a package, but another thing could be models, right? So, we're on a page here for the Earth magnetosphere, a tab here under the Earth magnetosphere page that lists models about that connect to the Earth magnetosphere, and those things we're being careful. Projects can hiccup if you increase the scope too fast, but I'll just say that that's something that we want to offer and we think will be valuable.
Thanks, Daniel. That's all I have.
Any other questions?
Quick one. Is it okay if I share the link to the staging area with maybe like 5 or 10 friends from plasma physics to make them jealous of what Helio has coming?
That's okay, but it's not gonna work after a couple days.
Got it. I'll let them
Appreciate
know.
it. Thank you, Nick.
Yep, you're building a tool everyone wants, Daniel. So if you let us share it, we're going to.
Oh, thank you.
Yeah, for that reason, I would maybe suggest giving it a few days before totally closing it off.
Okay, I'll give you a few days.
Thank you. Cool. Any remaining questions for Danielle? I suppose maybe it's a little premature, but you say you have years of funding for this. At what point do you plan to make this go public?
We're
Yeah.
looking at around AGU.
Okay, cool. So just later this year.
Yeah.
Cool. Well, I hope to see some kind of poster or something, maybe submitted to the PyHC session, just saying. Cool. Well, if
Awesome.
there are no final questions for Daniel, we can go ahead and wrap.
All right. Thank you for the opportunity to share this with you.
Thank you very much, Daniel, for sharing this with us. This is super cool. And I'm really excited that it's happening. All right. Well, looks like we don't have a whole lot of time for a FEP3 talk at the moment. Sorry, Sean, but I can give you some dedicated time at our next telecon in 2 weeks to talk what it's looking like then.
Cool, that'll work for me. Yeah, I'll just encourage people. Maybe I'll put the link in chat one more time if people want to go give any feedback on this little thing that I didn't really have much opportunity to talk about. Yep, there you go.
Awesome. Thanks, Sean. Rebecca, I see your hand.
Yeah, quick question. Is there a is there a FEP coming or already out about the levels of membership in PyHC, or is that still in the works?
It's still in the works. I've just been a little busy.
Okay. Sure. If
But
you want help drafting, I can give a little time to that. Just let me know.
I'll let you know. It had been in the books for me to try and get that cranked out either this week or next, now that all my projects that have week-long meetings have finally wrapped as of last week.
Yeah, I'm in the same boat.
Cool. Thanks, Rebecca. All
And
right.
maybe I'll just add that if you look at this PR here that I linked to, the main feedback I'm looking for right now is whether people think we should keep the scope limited to just what Python version we're supporting, or there's a big open question of, do we incorporate the versioning update policy from spec 0 about other packages like NumPy, Pandas, and Matplotlib? And I think they basically recommend like a 2-year update cycle. So, support Pandas version going back to whatever it was 2 years ago until current, and just kind of keep a sliding window like that moving forward. Something like that, if every PyHC package did get on board with, would obviously help a lot with interoperability. But that also is a bigger ask than simply asking you to support certain Python versions for certain windows of time. So that's the biggest open question. And if you have a big burning thought about that, I would encourage you to go leave a comment in the PR. And I can probably leave it there.
Sweet. Thank you. All right. See y'all again 2 weeks, same time, same place.
Thanks, everyone. Thanks, Daniel, for a great presentation.